The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to review for the Chapter 7 test, which will be tomorrow. So there will be no regular Zoom meeting at class time tomorrow. Just take your test. It's due no later than 11:59 tomorrow night. So don't wait until 11:50 to start it. All right, we had some questions. So I'm going to go ahead and do those to start with. This is from the, okay, it's not letting me write. Let's try now. There we go. The Chapter 7 review. We're going to start off with number 4. It says multiply and simplify if possible. So we've got x squared plus x over 3x minus 18 times 12x minus 72 over x squared plus 2x plus 1. Well, factoring everything, x squared plus x would be x times x plus 1, taking out the greatest common factor of an x. The denominator, taking out a 3, we get x minus 6. The 12x minus 72, factoring out a 12, we get x minus 6. And x squared plus 2x plus 1 is x plus 1 times x plus 1. So factoring everything, we get that. Then we can go back and cross out common factors in the numerator and the denominator. In the numerator and the denominator. 12 over 3 is 4 over 1. So on top I have 4x and on the bottom I have x plus 1. So there's the final answer. Any questions about that problem? All right, let's take a look at number 6, also from the chapter review. It says, find the perimeter and the area of the LED screen of the camera. Simplify your answer completely. All right, so we've got a rectangle, and across the top, it's 4 over x plus 6 units, and the height 3 over x minus 1 units. So tell you what, let's call this the length and this the width. So the perimeter is 2 times the length plus 2 times the width. So the perimeter is 2 times 4 over x plus 6 plus 2 times 3 over x minus 1. Okay. So that would give us what? 8 over x plus 6 plus 6 over x minus 1, just multiplying the numerators. Now, this is not an equation, so we can't multiply both sides by the LCD and clear the fractions. We can only build so that they have the same denominator and then add them together. So the LCD is what? X plus 6 times x minus 1. So here I need what, an x plus 1. Oh, that's x minus 1, my bad. Okay, let's find the eraser. Okay. So x minus 1 there. And so basically we'd need what? X plus 6 there. Why did I write an 8 there? Okay. Sorry. You know what? I'm going to back up a little bit. I kind of jumped over a couple of important steps. So let's go back here. I don't like using this whiteboard in this position because then I have to keep going back to erase things and stuff. But oh well, quit whining and go on. So my LCD is this. what do I need up here? I need an x minus 1 over an x minus 1, right? So this is going to be 8x minus 8. What do I need over here? I need an x plus 6 over x plus 6. So this is going to be a 6x plus 36. Okay, so now I've got two fractions with the same denominator. I'm going to add their numerators. 8x minus 8 plus 6x plus 36 over the LCD, which is 14x plus 28 over x plus 6 times x minus 1. You could factor a 14 out of the top and you'd get that. However, that doesn't allow you to reduce anything. So I would just go back to that, and that is units. Any questions there? All right, area is the length times the width. So that would be 4 over x plus 6 times 3 over x minus 1, which is 12 over x plus 6 times x minus 1. And that's square units. Any questions about that? Keep in mind, again, when you're adding or subtracting fractions, you need a common denominator. When you're multiplying or dividing fractions, you don't need a common denominator. All right, so this is your review time. What questions do you have for me? Anything? Anybody? Anything?
I do have a question on chapter review. Is for question number 5.
Okay, hang on. Let me bring it up. Let's see. Chapter review. Number 5. All right, is that it?
Yes.
Subtract and simplify if possible. Okay, so we're subtracting two fractions with the same denominator, so we're going to subtract the numerators. This is that thing I warned you about early on. Our numerator is going to be 4x minus the quantity x minus 3 over the denominator. Then we're going to distribute, so we're going to get 4x minus x, minus times minus is plus 3. So we're going to get 3x, 3x plus 3, 3x plus 3 over x minus 9. You okay with that, Antonia?
Yes.
All right. Any others you want to look at?
Yeah, give me a second. On number 8.
Still on the chapter review?
Yes.
Okay. All righty. Let's see here. I need to move things around so you can see it, so I can see it. Okay. A woman can bicycle 20 miles in the same time that it takes her to jog 10 miles. If she can ride 5 miles per hour faster than she can jog, how fast can she jog? Okay, so this is distance equals rate times time. So we're going to make a table. And let's see here. So distance equals rate times time. And we've got what? Bike and jog. A woman can bicycle 20 miles, so 20 miles, in the same time, so the times are equal, that she can jog 10 miles. So what do we know? We know that she bikes 20 miles in the same time she jogs 10 miles. It says if she can ride 5 miles per hour faster than she can jog. So this is, if this is R, this would be R plus 5. Are you okay with what I've got set up there so far?
Yes.
All right. So if distance equals rate times time, time equals distance divided by rate. So time equals distance divided by rate, distance divided by rate. But we know the times are equal, so our equation becomes 20 over R plus 5 equals 10 over R. The least common denominator of both sides is R times R plus 5. R times R plus 5. Over here, the R plus 5s reduce out and we have 20R. Over here, the R's reduce out and we have 10R plus 50. We'll subtract 10R from both sides. 10R equals 50. Divide by 10, R equals 5. And it said, how fast can she jog? So 5 miles per hour. I could probably jog 50 feet at 5 miles per hour, but 10 miles, I doubt it. You'd have to have an ambulance following me. You okay with that?
Yes, I'm just writing it down.
Righty.
5 miles per hour.
While she's doing that, anybody else have any questions you want to look at? Anything you want me to go over?
Will you be able to go on question number 7 as well, please?
Sure. You ready?
Yes.
Okay. If a number is subtracted from the denominator of 4/7 and twice as much is added to the numerator. All right. So how about if we let X equal the number, okay?
Mhm.
The number is subtracted from the denominator and twice as much is added to the numerator. The result is 7. You okay with that?
Yeah.
So we're going to multiply both sides by X, or 7 minus X. On the left side, I get 4 plus 2X. On the right side, I get 49 minus 7X. We'll add 7X to both sides. Subtract 4 from both sides. Divide by 9. X equals 5.
Okay, thank you.
Yeah, any other questions?
Yes, I do have questions, but it's from previous assignment, assignment 7-7.
Okay, hang on just a minute. 7-7. Okay. What questions?
Number 6.
All right. So this is from section 7.7 Number 6. The sum of a number and its reciprocal is 97 over 36. Find the number and its reciprocal. Okay, so how about if we do this? Let the number equal x. So then its reciprocal would be 1 over x. Okay, it's reciprocal.
Mhm.
So the sum of a number and its reciprocal is 97 over 36. There's our equation. The least common denominator is 36x. So we'll multiply both sides by 36x. Distributing on the left, I get 36x squared plus 36x times 1 over x. The x's would reduce out and we just have 36. Are you okay with that?
Yes.
And on the right side, we'll have 97x. So then I'm going to subtract 97x from both sides. And I've got a second degree equation. And it's a doozy of one, isn't it?
This one was.
Let's see here. Now, 97, 2 doesn't go in, 3 doesn't go in. So I don't think I can take out a greatest common factor, which is a shame. Let's see, 2 times 9, 3, nope. So A is 36, B is negative 97, and C is 36. The product, let's see, what's 36 times 36? 36, wow, 1296, and the sum is negative 97. I can see why you wouldn't want to do this problem. Okay, so the product is positive and the sum is negative. To get a positive product, you've either got to have positive times positive or negative times negative. But if you have positive times positive and then you add those two positive numbers, you can't get a negative sum. So what's the conclusion of all my babbling here? We've got two negative numbers, okay? So how about negative 1296 and negative 1? That would give me the correct product, but the sum would be negative 1297, which is way off. But the first number is even. So let's cut it in half. Negative 648 and negative 2. Okay, that would still give me a product of 1296. Now the sum would be negative 650. We're getting closer. Negative 648 is even. Let's cut it in half. Negative 324 and double the second one. Negative 324 times negative 4 is 1296. The sum is negative 328. It's even. Let's cut it in half. Half of negative 324 would be, let's see, negative 150 and negative 12, negative 162 and negative 8. Let's see, is that right? Let's make sure here. That's right. Okay.
Yes.
So the sum would be negative 170. But I can cut that in half, negative 81 and negative 16. And the sum is negative 97. Oh, there you go. Bingo. Okay. So there's our two numbers. 36x squared minus 81x minus 16x plus 36 equals 0. Factor by grouping, let's see. I could take a 9x out and I get a 4x minus 9. Here I get a 4x minus 9 and a minus 4. So I get 4x minus 9, 9x minus 4 equals 0. Well, if 4x minus 9 equals 0, then adding 9, we get 4x equals 9. Dividing by 4, we get x equals 9/4. If 9x minus 4 equals 0, adding 4, we get 9x equals 4. Dividing by 9, we get x equals 4/9. So hard to tell, this is a 9/4. So if x is 9/4, its reciprocal would be 4/9. Oh, if x is 4/9, its reciprocal would be 9/4. So the two numbers would be 9/4 and 4/9. Now, oh, notice it says smaller value, larger value. So you'd have to put 4/9 as your first answer and 9/4 as your second answer. Okay?
Okay.
Yeah, that was a tough one there. I'll admit that. Or I should say it took a while. All right, what else?
I have question, same assignment, question number 8.
Okay, and the others of you, if you're happy to just watch, that's fine. But if you have questions, we'll look at yours as well. So this is from 7.7, number 8. If the same number is added to both the numerator and denominator of the first measurement, let's see here, I'm gonna need to, what I need to do is make this smaller. Then we can make this larger. There we go. Okay. If the same number is added to both the numerator and the denominator of the first measurement, the result is the second measurement. Find the number. Okay, so what we've got here, from the bottom of the tape measure to here is 1 inch. And if you count, there are 16 little divisions. So this first measurement is 1/16. Okay.
Mm-hmm.
So we've got 1/16. If the same number is added to both the numerator and the denominator of the first measurement, the result is the second measurement. And the second measurement is 1, 2, 3, 4, 5, 6/16, which could also be reduced down to 3/8. You okay with that?
Yes, we're dividing them by 2, right? To get
Yeah.
that
Yeah.
3/8. Okay.
So now I'm going to multiply both sides by 8 times 16 plus x. 8 times 16 plus x. On the left side, the 16 plus x is reduced out, and I get 8 plus 8x equals. On the right, the 8's reduce out, and I get 48 plus 3x. Subtracting 3x from both sides, I get 5x plus 8 equals 48. Subtracting 8 from both sides, I get 5x equals 40. Divide both sides by 5 and x equals 8. Let's check our work. If this is true, then that should be true. Let's see. 1 plus 8 is 9. 16 plus 8 is 24. Yeah, that's true because we could divide top and the bottom both by 3 and we get the result. So the number is 8. Anybody?
You will help me out with number 10 on that same assignment.
Okay, give me just a second and I'll pull yours up. Okay. .7, number 10.
I was wondering, after we do his problem, can we do a couple of the finding the LCDs, please?
Absolutely, absolutely. All right, so this is 7.7, number 10. A plane can fly 360 miles in the same time it takes a car to go 210 miles. If the car travels 60 miles per hour slower than the plane, find the speed of the plane. So this is a distance, rate, time problem. So we've got plane, car. The plane can fly 360 miles in the same time, so the times are equal, but a car can go 210 miles. The car travels 60 miles an hour slower, so if the plane is R, the car would be R minus 60. Find the speed of the plane. All right, so far so good?
Yes.
All right, if distance equals rate times time, divide both sides by rate, time equals distance divided by rate. So the time of the plane is 360 over R. The time of the car is 210 over R minus 60. But since the times are equal, 360 over R equals 210 over R minus 60. So there's your equation. Your LCD is going to be R times R minus 60. On the left, the R's cancel out and we get or reduce out 360R minus, let's see here. Oh, what have I got? 360 times 60 is 21600. And on the right side, we have 210R. I'm going to subtract 210R from both sides. So I get 150R minus 21,600 equals 0. I'll add 21,600 to both sides. So 150R equals 21,600. Divide both sides by 150. 21,600 divided by 150 equals 144. So the speed of the plane, 144 miles per hour. All right with that one, Abel?
Yes. Yes.
Okay. Karina, you wanted to look at how to find the LCD?
Like, I'm trying to, I don't think it's LCD. I mean, like factoring a little better because I have really hard time factoring numbers.
Okay.
Equations.
Do you have any particular problems you'd like to look at?
No, I just need some practice, if that makes sense.
Yeah. Well, let's see here. We did, let's see, factoring. How about, let's take a look at 7.2, just a minute here. Let me see. Or maybe I should just pull up some problems out of the book. I could do that. Let's do that. Okay. So hang on a second. (7.2). Let's see. So I want, yeah, this screen. In fact, let's do this. I'm going to switch it over to the other screen. Okay. All right. So can you see my whiteboard now and just my whiteboard?
Yes.
All right. Here, let's take this problem. X squared minus 2x minus 35 over 3x squared plus 27x divided by 3x squared plus 17x plus 10 over 18x squared plus 12x. Okay, so we're dividing two rational expressions, two algebraic fractions, if you will. The first thing we're going to do is change subtraction to, not subtraction, excuse me, change division to multiplication of the reciprocal. Okay? Any questions about that?
No.
All right, now we're going to come back and we're going to factor each separate piece. So there we have a trinomial. It's in standard form. There's no greatest common factor. It's not a perfect square, but it does have a leading coefficient of a 1. So we're going to break it apart like that. Okay. For that problem, the product is negative 35 and the sum is negative 2. So how about negative 7 and 5? Are you okay with what I'm doing so far?
Yes.
Okay. Now let's come back and let's factor this one. Well, the greatest common factor would be 3x, and we have an x plus 9 left over. So all we're going to do there is take out the greatest common factor.
Okay.
Let's take a look at this one. 18x squared plus 12x. We're going to factor out a 6x and have 3x plus 2 left over. So far, so good?
Yes.
All right, now comes the tougher one. So let's take a look at that. Let's go to the next page with that one. 3x squared plus 17x plus 10. Do you prefer factoring by grouping or trial and check?
I like the grouping better.
Okay, that's what we'll use then. So A is 3, B is 17, and C is 10. The product is A times C, and the sum is B. So we're looking for two numbers whose product is 30 and whose sum is 17. The numbers have to both be positive or both be negative to get a positive product. But to get a positive sum, they couldn't both be negative. So we're looking for two positive numbers. How about 30 and 1? Well, that sum is 31. How about 15 and 2? Well, that sum is 17. There's our two numbers. Okay with that?
Yes.
So now we've got 3x squared plus 15x plus 2x plus 10. Factoring by grouping, we'll take a 3x out of the first two terms and have an x plus 5 left over. So we'll have an x plus 5 left over from the second group, and we'll need a plus 2 outside. So we have x plus 5 times 3x plus 2. Do you have everything copied down that you need there?
Yes.
All right, we're going to take this and take it back to the previous page. X plus 5, 3x plus 2. X plus 5, 3x plus 2. All right. So now that everything's factored, we can reduce out common factors. The x plus 5s reduce down to 1 over 1. The 3x plus 2s reduce down to 1 over 1. The 6x over 3x reduces to 2 over 1. In the numerator, I have 2 times x minus 7. In the denominator, I have what? X plus 9. Okay with that one?
Yes.
You want some more of those?
No, I just wanted to remind you before the test on how to split it up into grouping. I
Gotcha.
appreciate it.
Okay, sure. That's what they pay me the big bucks for, is to stay here and do this. All right, what else? Anybody, anything else?
Yes, can you please go over 7.7, number 11, please?
Okay, hang on just a minute. Let's see here. (7.7), number 11. Right. I'll find my mouse. Here it is. Believe it or not, I'm actually getting better at this than I used to be. Okay, let's see here. All right, so this was 7.7.
Yes, 7.7, number 11.
All right, let's change it back to black. Here we go. All right. On average, a Canada goose can fly 10 miles per hour faster than a great blue heron. In the same time that a Canada, I've always wondered, why don't they call it a Canadian goose, but whatever, that a Canada goose can fly 150 miles, a heron can fly 100 miles. Find the flying speed of each bird. Okay, so this is another distance equals rate times time. We've got the goose and the heron. All right. Canada goose can fly 10 miles an hour faster than a great blue heron. So if the heron goes that fast, the Canada goose would be that fast plus 10. In the same time, so the times are equal, that a Canada goose can fly 150 miles, a heron can fly 100 miles. Find the flying speed of each bird. Now, I'm curious, if it's a Canadian goose, wouldn't it be using the metric system? So wouldn't it be flying kilometers instead of miles? I'm just saying. All right. So if distance equals rate times time, and we divide both sides by rate, time equals distance divided by rate. So the time for the goose is 150 over r plus 10. The time for the heron is 100 over r. Since the times are equal, our equation becomes 150 over r plus 10 equals 100 over r. Okay. Any questions there?
No.
The least common denominator is r times r plus 10, r times r plus 10. On the left, the r plus 10s go away and we have 150r. On the right, the r's go away, and distributing we have 100r plus 1000. subtract 100R from both sides. 50R equals 1,000. Divide both sides by 50R equals 20. So the heron goes 20 miles per hour and the goose goes 20 plus 10, which is 30 miles per hour. So heron 20 miles per hour, goose 30 miles per hour. All righty.
Yes, thank you.
What's next? Anybody? All righty. Well, I will be back this afternoon at 1:15. Should you come up with anything else? Otherwise, again, tomorrow there's no meeting at 11:30. If you show up, there'll be a message saying, just take your test and just take your test. So have a great rest of the day. I'm going to stop the recording.